Let's simplify 2/5 divided by 3. It's a little awkward to divide a fraction by a non-fraction, so I'd like to change the 3 into 3 over 1 first. Also, let's recall that dividing two fractions is the same as multiplying by the reciprocal of the second fraction. So 2/5 divided by 3, I'd rather call this 2/5 divided by 3 over 1, and then change the division to multiplication, but the cost of doing that is to rewrite the second fraction by reciprocating. So you have 2/5 times, instead of 3 over 1, we'll have 1 over 3. Now, for multiplying fractions, recall our rule that we had discovered was to multiply just straight across. Don't try to cross multiply, just multiply straight across. And so you have 2 times 1 over 5 times 3, in other words, 2 over 15. It's okay to skip a lot of this work, but I just wanted to show, for instance, I wanted to show 2/5 times 1/3 equals 2 times 1 over 5 times 3 to really show visually how the work that goes from here to there is applying this true formula. That it's literally just applying a formula that we have seen, right? And just as a friendly reminder, um, there aren't necessarily standard letters A, B, C, D. So the same formula, a fraction multiplying a fraction by another, the, this can be presented using RTSs and U's and whatever. And the whole point of a formula being written like this is trying to communicate that this formula and where the letters appear, where the variables appear in the formula, is trying to communicate how to properly multiply two fractions together. Okay, this is going to be useful again a little later today. So I'd like to take this ladder diagram, as I like to call it, because we're going to look at some exponents. And I've started with 2 squared equals 4 and 3 cubed 2 cubed equals 8 and 2 to the 4th equals 16. And what goes there? What's got to go here in this spot if we were to follow a pattern? And I would say don't just say 1. I mean, sure, the exponent is the thing that's changing, but shouldn't we say 2 to the 1? And now we should address this question here of how do you start at 4 and get to 8 and then start at 8 and move up to get to 16? Each time you should, there's 2 ways to say it. I've heard people say times 2, multiply by 2. And the other way I've heard people say it is double it. And both are totally fine. And so then double it or multiply by 2. So then the question is, how do you go down, right? So to go down, you're going to have to undo times 2. So you'd have to divide by 2 or cut in half. So that's why there should be a 2 here, right? So 16 divided by 2, you get 8. 8 divided by 2, you get 4. 4 divided by 2, aha, that's why there's a 2 here. So we have 2 to the 1 is equal to 2 and filled in that part of this exponent ladder. This happens in general, by the way. So you'll also see that 3 to the 1 equals 3 and 4 to the 1 equals 4. Or to summarize, a to the 1 is equal to a. Okay, that's a new formula for us. Instead of filling this in right away, I think it's important to discuss because sometimes people overthink when the exponent is 1. And doing this little experiment, if you ever forget, recreating this will help. So what goes in these spots? Well, let's follow this pattern. Take a look. The base is always 2 on the left side. And the exponent should go down by 1 unit at a time. So I hope this makes sense. 2 to the 0, 2 to the negative 1, 2 to the negative 2. And remember, going down 1 step on this ladder, on the right side, we divided by 2. So take a look here. 2, if we divide by 2, well, 2 divided by 2 is 1, right? That's, in fact, if you recall the 2 cats, 2 boxes, so it'd be 1 cat per box. That's where this 1 comes from. So we'll fill that in, right? So we get 2 to the 0th is equal to 1. And if you were to follow a similar story, you'd also see that 3 to the 0th equals 1 and 4 to the 0th equals 1. So we'll summarize this by saying that a to the 0th is equal to 1. Now let's take 1 and divide by 2 to figure out what goes in this spot, right? Again, to go down 1 step, we should divide by 2. If you do 1 divided by 2, it's just literally 1 divided by 2, so you get a half. Now let's go 1 step lower. So start with 1/2 and you have to divide by 2. Ooh, 1/2 divided by 2, that looks funky. A fraction divided by a non-fraction. That was exactly the warm-up we started with. So let's rewrite this 2 as a 2 over 1 and then change the division to become multiplied by reciprocal. So the 1/2 that was here copied, and then 2 over 1 became 1 over 2 with a multiplication sign. Multiply straight across. You have 1 times 1 is 1, and 2 times 2 is 4. So you get 1/4, and we wrote this here. Next step down, 1/4, you need to divide by 2, and so that's going to be So 1/4 divided by 2 over 1 is 1/4 times 1 over 2, and multiply straight across, you get 1/8, and then last one here is going to be 1/16. By the way, we can rewrite the denominator. So in 1 over 16, the denominator is a 16, and another way to write 16 is 2 to the 4th, right? Since 16 can get replaced with 2 to the 4th, we saw up here 2 to the 4th is 16. So I rewrote this, just stepping back and forth in the slides. So instead of 1 over 16, I'd like to write 1 over 2 to the 4th. In the same way, these other ones, 1 over 2, 1 over 4, 1 over 8, I'd like to rewrite how the denominator looks. I won't touch the numerator, it'll just be 1 each time. But I'll rewrite this as 1 over 2 to the 1, and then 1 over 2 to the 2, 1 over 2 to the 3, and so on. There's a good reason to do this, because these bottom 4 then, we can notice the following pattern, that a to the negative nth power equals 1 over a to the nth power. So you should try this with base 3. Maybe pause this, try it on your own, and then the next slide shows what the final result should look like. Okay, you get a thing that I hope looks like this. And whether it was with the base 2 exponent ladder or this base 3 exponent ladder here, we discover these three formulas, namely a to the first equals a. Right? This is trying to say anything raised to the first power equals that thing. So 7 to the first is equal to 7. 8 to the first is equal to 8. And then a raised to the 0th is equal to 1. That is, 25 raised to the 0th is equal to 1. Sometimes people overthink this and say that the final answer would be 0. So if you're ever confused, you can always recreate the exponent ladder. And then finally, the bottom 4 rungs here show a to the negative nth is equal to 1 over a to the positive nth. Notice why is it just a positive n and why no more minus sign? Because look over here on the right side in the denominator, there's no minus signs in the exponent. This is trying to tell us that a negative exponent translates into a positive exponent at the cost of pushing the thing into the denominator. So if you ever forget these three formulas, you should recreate the exponent ladder. The whole point of going through this is to convince you that these formulas are true. And if you were to ever forget these formulas, you can recreate the story. This is a very pattern-driven story that you can recreate. And part of this is trying to intervene because people tend to accidentally say a to the 0th equals 0, which isn't true. People tend to accidentally take a to the negative nth and should turn it into 1 over a to the nth, but instead accidentally just push the minus sign in front. This is made up stuff.